Okay, page 9, graphing tangent. So a tangent looks totally different. We know on the unit circle tangent is sine over cosine and all that, but we just want to focus on what the graph ends up looking like. So we're still going to have that midline. For tangent's parent graph, the midline is just the x-axis. Then what we want to look at is that tangent starts on the midline. So this point is the middle of the tangent graph. And then I'm just going to fill this in. At negative pi over 2, there would be another asymptote. Those actually are asymptotes, those vertical lines. So the middle of the asymptotes is the first point of tangent. Obviously, tangent would finish down like this. Then what we're going to have to do is we're going to have to take the period. So the distance between asymptotes is the period. For parent graph, it's just pi. But for tangent in general, it's pi over b. That's different than sine and cosine, right? Pi divided by b. So we're going to take the period and we're going to cut it in half. So the period over 2 that way, and then the period over 2 that way, and it'll give us the asymptotes. Both asymptotes. And then the middle of those sections. So what have I been doing? I've been doing yellow. So between the asymptote and the red dot this way, there's a section half my graph. Between the asymptote and the middle this way is half my graph. Tangent kind of looks like a positive cubic. It is in no way related to a cubic, but I understand that's kind of what it looks like. If you go to the right, in the middle of that purple section, you go the amplitude. So here is, I've been making it orange in the past. Here is my A value. And then the middle of the yellow section, you instantly go down your A value, opposite A. So it'll make more sense as we start doing the examples. Okay, so example A. So our answer blanks change a little bit for tangent. Tangent does not have an amplitude. It doesn't have a hill and a valley. It has a vertical stretch, just like parabolas and everything else do. It does have a period. It does have a phase. And it does have a vertical shift. We do need to know if it has a vertical reflection. Yes, no. And then now we're going to want to know the middle of tangent, and we're going to want to know the asymptotes. We can figure everything else out if we have that. So let's look at what we have. There is a negative sign in the front. So that tells me there's no stretch, right? Because that's an imaginary 1. When you have a parabola of 1x squared, it has no stretch. So this is none. Then the vertical reflection, it's negative, so yes. The period is 2 pi over b. Nope, sorry. The period is pi over b. There's an imaginary 1 in front of this x, so that's why I'm dividing by 1. So the period's going to be pi. The phase, it says plus pi, but we know that's going to move it left pi. And the vertical shift, we see plus 0, so it has no vertical shift. Or you could say up 0 if that's helpful. So the middle is going to be exactly where the phase is. Because remember over here the middle was at 0? So if I'm going to move this thing left and right and up and down, that's where my phase is going to be. So the middle is going to be left, so negative pi will be the middle of my tangent function. And then my asymptotes, you're going to do middle plus n minus half the period. That's not what I want to write, sorry. Period over 2. Because half of the graph is to the left of the middle and half of the graph is to the right of the middle. So my middle is negative pi, and I'm going to add my period was pi, coincidentally, so half of that, pi over 2. Make a common denominator. And then do the same thing with minus. This is where I take my work right here. Well, not that far. Take this work and make it minus, right? I already have my common denominator. Make it minus. That tells me where my asymptotes are going to be. So you're welcome to graph either one first. Let's graph the asymptotes. So negative 3 pi over 2 is a vertical asymptote. For some reason I made them different colors. So negative pi over 2 is a vertical asymptote. Hopefully the middle of that, let's make our graph purple, is at negative pi, which matched my thing. And remember, sorry, I skipped it, but my green line hasn't moved because there is no vertical shift. So there's the green line. So my middle, negative pi, is on the green line for tangent. Then I cut that in pieces. It does not have a vertical reflection. Oh, I circled no, you guys. Sorry. Vertical reflection. Yes, because it's negative, right? There's a negative sign right there. So that means my cubic, I know it's not a cubic, but it kind of looks like a cubic. It's going to go downhill. So in the right gap, so let's color code them again. I don't know why I've been making them yellow and purple, but let's stick with it. So in my purple gap, I need to go down 1. So in the middle, down 1 unit. In my yellow gap, I need to go up 1. The middle of that yellow piece, up 1. Try to make it look like a tangent graph hugging the asymptotes. And it would repeat just like sine and cosine repeat, but we just graph 1 period of tangent. Okay, B. Answer blanks. Okay, I did all my answer blanks. Let's highlight some stuff. Okay, so the vertical stretch, because it's a 2, it is stretched vertically. If it was a 1/2, I would say compressed vertically. It's positive, so there is no vertical reflection this time. The period is pi divided by b, which is an imaginary 1, so the period is pi. Phase, it says minus pi over 2, so that's actually going to move it right pi over 2. Vertical shift is down 1. The middle is going to be at my phase. Right pi over 2 is positive pi over 2. The asymptotes are going to be the middle plus my period, and then later the middle minus my period. I like to use that common denominator equation again. Why do the math twice? Okay, so my asymptote's at negative pi over 2. My other asymptote is at 3 pi over 2. Wait a second. How many of you caught what I did? So it's not plus minus the period. I apologize. It's plus minus period over 2. So my period is pi, but it's half of that we add and subtract. So that's 2 pi over 2, or pi if you want to reduce it. And then pi over 2 minus half the period will give me 0. So I have an asymptote at 0. Again, I apologize. And an asymptote at pi. My vertical shift is down 1. The middle should land right in between those asymptotes, pi over 2, and right on the green line. Vertically stretched by 2, so no reflection. So let's do yellow and purple again. Positive means it goes uphill. So the purple gap, right in the middle, from the green line, you go up 2. The yellow gap, from the green line, you go down 2. And try to make it look like a tangent curve. Try to hit the dots also. Okay, that's tangent. My suggestion is that you study sine and cosine very, very well, and have a general understanding of tangent for this class. Hope you're doing well.